All right, so today's lesson is about linear equations. Linear equations in one variable. So last time we talked about, so let's do a definition here for equations. So last time we talked about expressions, or to be specific, we're talking about algebraic expressions. What do we mean by an algebraic expression again?
As a constant and a variable.
Exactly. So something like 2x plus 1. So we have variables and letters together, they make an algebraic expression. So how do we make this expression? How do you make it an equation?
You have to put an equal sign.
Exactly. It's all just missing an equal sign. That's why the reason why we call it equation, because there's an equal sign. And then we need some other side. Could be some other variables and numbers. It could be something as simple as, let's say, for example, 4. So this is what we call an equation. Two equal sides, two equal statements. Equations, or sometimes it's called equality. And this specific type of equations we're talking about today is called linear equations, or also called first degree equations. First degree or linear. Linear equations, and the reason, what exactly makes this a linear equation?
It only has one power.
That's right, the power of the variable is 1. If the power of the variable is 1, it makes it first degree or linear. So these are the same. First degree or linear equations mean the exact same thing. That happens again, it happens when the power is 1. If the power of the variable is something other than 1, then it's a different type of equation. For example, if it's 2, it's second degree or quadratic, which we're going to learn in the future. If it's 3, it's cubic or third degree, and so on. But today we're only going to be talking about first degree or linear equations. See how to solve them, from simple ones to a little more advanced ones with multiple fractions and multiple terms on both sides. Okay, so basically an equation is always has a variable or more variables, and that variable is usually unknown. We try to solve for it. We try to find that variable. It's basically a mathematical statement written in these symbols, arithmetic symbols like these, math symbols. So let's before we get to that problem, let's take a much simpler one. When we say, for example, x plus 1 is 5, you can say this is a sentence. You can say a number, an unknown number, added to 1 is 5. So what's that number? That's an example of a simple first degree equation. We all know what that number is, right? That number, of course, is
4.
That's 4. That's right. And when we say 4, we say that's the solution to this equation. So there's only one number that makes this equality true, that validates this statement. Other than 4, no other number can make that true. So to solve this basically means to get the x by itself. What is the value of x? That's the purpose of solving, to get the variable by itself and solve. So we think about isolating the variable, getting it by itself. Here the variable is not by itself. Variable x, or the unknown x, is next to a number. So we need to eliminate this number. Once we eliminate it, we'll get the x by itself. Once we get the x by itself without a minus or a fraction or a number after, then we can consider that the solution. So positive 1, as we saw last time, the additive inverse, or did we do that? Okay, the what is the opposite of positive 1?
Negative 1.
Negative 1. So we saw the other day how we combine a number and its opposite, and they cancel each other out. So if we combine these two, we subtract 1 from here, these cancel out, get x by itself. It's an equation. You gotta do whatever you do here, you have to do the exact same thing on both sides. So if we subtract 1 from here, you gotta subtract 1 from here. So you end up with 4. So that's the solution to that equation. I know some of you just like to move this over. That's fine. You can do that. Some people like to move this over and change the sign. It works the same way. So once you solve your equation, so this is now a proposed solution. So x4, we call that a proposed solution. So we need to check to make sure this solution is valid. Okay, so we call it a proposed solution. And then you want to check to make sure your solution works. To check, you take your proposed answer and you plug it in the very first equation you started with. So x plus 1 is 5. So you say, okay, let me plug this x4 into the equation. So it's going to be, instead of x, we're going to put 4 plus 1 equals 5. This point, we're not sure yet. We're trying to check, so we need to put that little question mark over the equal sign. So we're not sure yet until we simplify both sides and see if we get two equal numbers or statements. So of course, 4 plus 1 is 5. Also, other side is 5. So this checks. Once you get the same number on both sides, we say that the solution is valid or it checks. Okay, so that's the whole idea of linear equations. Just find in the x, plug in the x to check, and once you do that, so now you can confirm that this is the actual solution. Okay,
so we can do x equal to minus 1 plus 5 and x is equal to 4, right?
You can do that, yeah.
Okay, because yeah, for me it's that way. It's easy.
Yeah, that's fine. So you can do that. This over. Okay. So in this case, this equation has one solution, okay, or only one number satisfies this equation. So it has one condition. Only this condition makes this true. That's why we call this a conditional equation. Okay, because it has one solution. Sometimes it may have many solutions, or it may have none. We'll see that later. Okay, so that's basically the concept of equations. Let's do another problem. So in general, all the equations have this standard form. So the standard form is something like this: ax plus b equals some c. Okay, all the equations are in this form. For example, in this one, the a is 2, this is the b, and this is the c. So it changes from one equation to the other, but it's always in the standard form. And of course, the x must be 2 power 1. The x here doesn't have a power, means it has an invisible one, which makes it linear or quadratic. Otherwise, it won't be linear or first degree. Otherwise, it will be something different, like quadratic.
What's that you have written in the front there? Before the x?
Here?
No, before the x.
ax plus b equals c. Okay, that's, if you can't see that, that's a. All right, let's get back to our original problem here and try to solve that. So 2x plus 1 equals, my pen is still acting up, it's a little slippery. Okay, so for, what was that, 4? Well, actually, let's use 3 to make things easier. So this looks almost exactly like this. So again, the a is 2, the b, and the c. So the purpose again is to get the x by itself. That's the purpose of solving first degree equations. So we need to isolate the x here. If we look at over here, we have the x, but it's not by itself. We need to cancel any other numbers and just try to have the x by itself like here. So we need to cancel basically the 1 and the 2. Always start with the number that's not next to the x, not the coefficient of x. So we're going to cancel this one here before we get to the x. So again, same thing. The opposite of -1, do that on both sides. So these cancel, so you end up with 2x equals 3 take away 1, which is 2. We still don't have the x by itself. We need to cancel these two. We have 2 times x. This is a multiplication What is the opposite of multiplication to get rid of the 2?
Division.
Division.
That's right. So to get rid of these 2, divide by itself. Also here, divide the other side by the same thing, not by these 2 here, but whatever you use here, use the exact same number here. Finally, 2 and 2 cancel out, that's 1, or 1x, or simply x, and 2 by 2 is also 1. So that's our solution. X is 1. So as always, we can maybe write this, x is 1. We can also check this. So this is something you need to do on the side, check in your solution. You don't have to show it that necessarily, but it's a good practice to do it on the side to make sure you got the right answer. So, and when you plug, make sure you plug in the very first equation, not another version of it. This is the one that we started with, so we're gonna plug it in here. So we're gonna do 2 times x, 2x, 2 times x, which is 1, plus 1 equals 3. And again, we're not sure yet, so we cannot use this like this. We have to use that little question mark until we check. So then we simplify. Which operation is done first here?
Parentheses.
Multiplication.
That's right, the multiplication. If we had something inside, we would simplify it first, but there's only one number here, so we're just going to do the multiplication 2 plus 1 equals 3. Again, we still need that question mark until we confirm. 2 plus 3 plus 1, that's 3. Also 3, that checks. We don't need that question mark here anymore because we know for a fact that 3 is equal to 3. Okay, so the equation could be as simple as this, or may have more x's, more numbers, and parentheses. As we go, we're going to try to make the problems more interesting, a little more, not complex, but just longer. Depending how, for example here, how many steps did it take us to solve this? Took 1 step, right? 1 step, subtract, we get our solution. So this is a first, not first, but let's say a 1-step equation. Okay, 1-step equation. How many steps did this one take?
2.
2 steps, that's right. So this is a 2-step. 2-step equation. And as we go, we may have more or less, more steps depending on how long the equation is. So 2-step equation. Let's do another one. Let's say 2, maybe x minus 1. And plus 3, probably maybe 11 here. So this one is a little longer. So we have 2, we have parentheses, and plus, and an equal sign. So again, the longer the equation is, the more steps it will take to solve it. So what do you think we do first here for this equation?
Multiplication.
Again?
Multiplication.
Distribute. That's right. That's the distributive property we learned the other day when we talked about algebraic expression. So consider the left side as an expression. Forget about the equal sign on this side. This is an algebraic expression, and the other day we'll learn how to simplify them using the properties of real numbers. So first we're going to use the distributive property to multiply, so that's 2x minus 2. Bring the positive 3 down here, equal 11. So we're still working on this side, try to simplify it as much as possible. So what combines here, or what simplifies on this side?
The negative 2 plus 3.
Exactly, these are like terms, they're both constants, not variables. So there's no x to combine with this, it stays the same. And these two, of course, negative 2 plus 3, that's positive 1. And 1. So once we simplified it, now it looks something like this. So we're going to repeat these steps again to solve. Okay, so we're going to cancel positive 1, cancel the Then we're going to cancel the 2 here. So just like we did the previous example, so we're going to subtract 1, subtract 1. So we end up with 2x. These cancel out. Equal sign and 10. Finally, what do you do?
Divide 2. Divide 2.
Exactly. So we're going to divide by 2. Divide both sides by 2 in order to cancel the 2. Again, solving means getting the x by itself. So x is 5. And again, let's check for one more time.
Bring your page up, Professor.
Mm-hmm.
Thank you.
All right. So now, let me fix it. Now we're gonna do the same thing. We're gonna take this 5. It's a proposed solution until we verify it. So we're gonna plug this into this. So we're gonna do 2 parentheses instead of x. I'm gonna use the 5. That's the solution. The possible or the proposed solution plus 3 is 11. Again, we don't know for a fact whether this is equal or not. We have to use that question mark. And after that, use the order of operations to simplify here. Where do you start from to simplify this expression?
You have to do what's in the parentheses first.
Exactly, PEM does. So for those of you who are not aware, the order of operations is summarized here is as PEMDAS. Parentheses, exponents, multiplication, division, addition, subtraction. Always start with parentheses. By that we mean inside the parentheses, so that's 4 plus 3. Still not sure. Then after the parentheses, exponent or powers, we don't have that. Then the multiplication, which is here, so that's 8 plus 3 is 11. Finally, 8 plus 3, that's 11. Also 11. That works, that checks. So this is, in fact,
True.
the solution. That's right. This is, in fact, the solution of the equation. So if you get something here that's not, doesn't make sense, 7 equal to 5 or whatever, that means there is something wrong. First, start here. Maybe you made a mistake here. Before you go check your equation, you might have made a mistake here, the sign, or you messed up the order of operations before you go back and check the equation. So you kind of backtrack. So from here, line by line, and then go back all the way to the equation, backtrack all the way to the original file. Okay, usually it's a little mistake, a silly sign or something like that. This happens a lot, especially if you don't know your signs very well. So make sure you know your signs of addition, subtraction, multiplication, and division. You need to know those very, very well. One mistake here could make the whole thing wrong, and you waste time going back and forth to pinpoint your mistake. Okay, so review your rules of additions and operations. This makes it easier and faster. Okay, is everyone okay so far?
Yes.
Everybody, please let me know.
Yes.
All right.
Yeah, we're good.
Let me know if you have any questions, or if you don't understand a problem, let me know so we can repeat it or do another one. I have plenty of more examples coming. Let's do another one. Make things a little more interesting again. This time, we have something like this. Okay, what do you notice about this equation? How is it different from all the previous one we saw so far?
There are variables on both
X's
sides.
on both sides.
Exactly. So if x here and x here, it doesn't always have to be like this. You may have x's on both sides. Believe it or not, we can change it a little bit. It's still going to be in this form, even though you see x's on both sides. If you move the x that's here to this side and combine them, then it ends up being on this side. This is a standard form, but sometimes you have to work for it to get it to this point. It's not always written conveniently like this. You may have to do some steps in order to get it to standard form. But when it's an equation like this, first, always try to work on each side separately. Consider each side as an expression, just like we did here. And work on it, try to simplify it as much as possible. Before you start moving things around or subtracting from both sides, you want to work on each side independently. There's not much we can do here. These are unlike terms. There's no parentheses, no like terms are combined. Same thing here. But if we had, we would do this first. Once you do that, so we need to have, this is an important step here. We need to have the x's on one side and the numbers on the other side. Because the purpose again is to isolate the x on one side and have some solution on the other side. So we can do this at the same time in an easy way. Just move the x from here next to this one and move the constant here next to the constant on the other side. But something interesting happens when you move something to the other side of the equal sign. What is it?
To change the
To
sign.
change the sign.
Exactly. Whenever you move a term across the equal sign, not just within the same side. If you move to x over to here, you will not change the sign. If you move it across the equal sign, make sure you change the sign of that term. So we can do both of these at the same time instead of doing +1 and +1 and then doing minus 2x and minus 2x. This is faster and convenient and easier as opposed to the other method. So 3x, 2x, it's a positive here, and then if it's a positive,
Minus.
that's right.
Minus 2x.
Exactly, 22, negative 2x. This negative one, again, like I told you before with the
Yes.
expressions,
It's
every term,
+1.
that's right, every term has its sign to the left. So we're going to move the negative one over across the equal sign to combine it with this. So this will turn into +1.
Mm-hmm.
And this +7 stays the same. We are not moving it. It's still on the right side, so the sign remains the same. That's important, okay? You can do two steps in one like this. Now we're going to simplify 3x minus 2x. That's 1x, or simply x, and of course 8.
8.
No need to put the 1 and divide by 1. 1 times x is just x. Okay, so keep that in mind if you have x's on both sides. After you simplify each side, move the x's to one side and the numbers to the other. It doesn't matter on which side you put the x's or the numbers, as long as you put all the x's or both x's on one side and the numbers on the other. That's all that matters. Okay, let's see now a case where it's not here. It's not at this stage yet, but maybe we have some parentheses and some parentheses here and see how to deal with that. So this was pretty simple. Just move things around right away. So let's say, something like this, and maybe -4. On the other side, you may have, let's say this, and probably something like this. Okay, so things are getting a lot of interesting, as you can see. The equation is longer, so this may take more steps than the previous ones. Again, don't let this fool you. It doesn't have to be that complex. It's just something in the standard form. You can easily change that into something like this. You just happen to have more terms and parentheses, but we do know how to simplify algebraic expressions, so we're going to use that. All right, so what do you want to do first here?
Multiply it 3
Distribute.
with the parentheses.
Oh, okay, distribute. So whenever you see parentheses, you want to do that first. Please mute your mic if you have background noise. So this will require more steps. So I'm going to write those steps here as we go. So first thing you want to do is, actually, let me write that down. Starting from here. So first, I want to simplify each side first. Doesn't matter how many terms you have on each side. Work on each side. And on each side, we need to do a couple of things. First, clear the parentheses, meaning distribute. After clearing the parentheses, okay, let's first clear the parentheses. So we're going to work on each side independently, also simultaneously. We're going to do this and do this, but each one on its own. So instead, we're going to distribute. Okay, so start the same process here independently. So -5 5 and positive 2x. If you want to make things a little more interesting, you can add maybe a 1 here. Add a 1 also here. Okay. Now back to this side. What do we combine?
It'll be on -10.
That's right, -10. And on this side, we're going to combine -1 and the -5 and the 1, right? Which will be -4 plus 2x by itself. Okay, so -5 and 1 here. The 2x stay the same sign because it doesn't have a like term. Now, does it look like this? It almost kind of looks like this. We're just going to do the same as we did here, and we should have our solution. So clear the parentheses, combine like terms. That's the first step. That's where we're up to now. What is the second step? What is the second
You
step?
gotta put the x, 2x in the first equation.
Exactly. So basically, we're going to repeat the same process here. So we simplified each side completely. There's nothing else combined. Now it's time to repeat the process here. So we want the x's to be on one side. So we're going to take this positive x. We're going to move it over next to this one. We're going to take the -10, move it over next to -4. So 3x stays the same. Again, positive 2x. If it moves over, we want to change that sign.
Minus.
That's right, -2x. Equal sign. And what else?
Positive 10 minus 4.
Exactly. So -10 moves over, becomes +10. This stays the same, -4. So that's 1x or x.
6.
And +6. And that's your final answer. Again, for your own good or your own purposes, you can always check this on the side. So simplify each side first. Okay. So move the x's or the x's or the whatever letter you have. Move the x's to one side. And the numbers to the other. To the other. And finally, one final step, if we end up with a number here, 2x or -3x or whatever, you do want to add another step. You still have to isolate the x. It's not always the case that you end up like this. You may end up with a number here next to the x, so you want to add one third step. You can say the third step here is to isolate the x. So you may have to either add, subtract, multiply, or divide. These are the properties of first degree equations. When you add to both sides or subtract from both sides, or whatever you do on both sides, those are called the properties of linear equations, properties of addition, subtraction, multiplication, or division. Okay, so remember these main steps. It doesn't matter how long the equation is. It doesn't matter how complex it is. You already know what to do. All you have to do is follow these steps. You don't have to think about it too much. You don't have to invent anything. Just go by this checklist. Simplify if you have to, move to one side, and isolate the x if it's not by itself. Okay, that's probably as complex as you can get, but it doesn't have to be that complex as you saw here. We just need to follow these steps to simplify it first. You guys okay so far? Any questions? Everybody?
No
Everything's good.
question.
No.
No.
Okay. So please, again, feel free to ask or answer questions whenever. Now let's look at another example here. want to show you something before. Sometimes we may have, let's say, -3 plus 6, maybe -12. Okay, that's another example. It's much like we did earlier, but it's a little, there's a common mistake that people make here. I want to make sure you don't make that mistake. So where do we start from again to solve this equation? What do we cancel first?
You're gonna -6 on both
Okay, we
sides.
need to get rid of -6. I mean the 6 by subtracting from both sides. And -6 here, -6 here. These cancel, so we end up with -3x. And this is -12 minus 6 is
-18.
-18.
That's right, -18. Now, what is the next step? Well, one final step, basically.
Divide by -3.
Exactly. So when you divide here, again, the operation is multiplication. So if to cancel the -3, you want to divide it by itself, not do +3. A lot of people make a mistake with +3. Basically, earlier we saw that when we have something like this is a multiplication. We divide by this number to cancel it. Same thing here. We're going to divide by this number to cancel it, which happens to be -3. Not just 3, or do not add 3. So you want to divide by -3. Also -3 on this side. So negative and negative cancel out. Basically, a number divided by itself cancel out. And of course, this turns into
That's
negative.
6.
That's right, negative divided negative, just like multiplication. Turns into positive and 6. Keep that in mind. You don't want to make that mistake. And there's another one quite similar to that. Let's say you have -x plus 2 is 5. You want to solve this equation. It's a two-step equation, much like this. So we're going to subtract 2. Subtract 2. Cancel these, so you get this and 3. Are we done? Did we solve for x?
No,
No.
you divide by -1.
Exactly. So if you have a -x here, this is basically technically a -1. When you see a negative in front of the parentheses or in front of a variable, consider that a -1. So if you want to cancel that -1 the exact same way, we canceled the -3. So you want to, so you want to divide by -1. Make sure you do that on both sides. So -1 and -1 cancel each other out. You end up with x by itself, positive. That's how you want to use solution. Just x without a minus, without a number here or after. And of course, this is a division. 3 divided by -1 is -3. And that's your solution, okay? So when you see a negative next to a variable, you want to cancel that negative, whether it's a negative by itself or a negative number, you want to divide by that negative number. We'll divide that number by itself to get rid of it. Okay, so now that's pretty much as long as the equations can get. Now we're going to move on to another type of equations. I mean, the same type, but with a slightly different form. We're going to see how to do equations with fractions. So far, we haven't seen any fractions. So we're going to see how to solve equations with 1 fraction, with 2, with 3, even more. Even if you have 4 fractions in one equation, we're going to see how to solve that. Okay, so let me actually show you one more thing before we go to the fractions. So far every equation we saw was a conditional equation. Conditional equation because it has one solution. We have a couple more types of equations. If you say, okay, if you look at this problem here and you want to solve it, just follow the same steps. So we need to move this over, move the negative over. So this turns into 5x. 5x and minus this 5x equals -1 becomes +1 plus 2. What is 5x? Take away 5x.
X.
Two opposites. No, it's not x.
0.
0. Remember last time when we combined the number and its opposite, we cancel each other out. So 5x, a number take away itself, is 0. So these are gone with 0. And 3. What do you think of this statement? 0 equal 3. What
It's
do you
an
think?
inequality.
That's right. This is a contradiction. It's inequality. It's not an equation. 0 is not equal to 3. So this equation basically does not have a solution. It doesn't make any sense. There's no x that you would plug to make this true, to end up with something that makes sense. So this basically we say this is a contradiction. Doesn't make sense. So no solution. Okay, so if you come across something like this and you end up with a statement that doesn't make sense, first make sure you didn't make a mistake, first of all, before you can confirm this, or before you can rely on this as a solution. Make sure you didn't make a mistake. But if you end up with something like this, that's a contradiction. Just say no solution. So we have conditional equations, we have contradictions, okay? And the third type is when you have, let's say, okay, that's an equation. Let's try to solve this and see what we get. So again, we're gonna start from the parentheses, the left side -2. This stays the same. Okay, we're gonna repeat the same process. We're gonna move this over. And we're gonna move the -2 back. So we're gonna move, it's gonna be 2x. This moves over here, becomes -2x. And the -2 moves over, becomes +2. And then bring this -2 down. Again, what is 2x? Take away 2x.
X.
0.
0.
0, they cancel each other out. And what's +2 minus 2?
0.
Also 0, right? Again, they're opposites. Same values, but different signs. Now, what do you think about this statement? Is there a contradiction like this one?
No, 0 is
No.
equal to 0.
So that's a fine statement. It's a valid statement here. There's no problem with it. But you'll notice that the x is gone, right? There is no x here. We just have a number that's equal to itself. You could have 5 equals 5, 1, 1. What do you think of this equation compared to this one? This one is a contradiction, has no solution. But what do you think of this one? It's not a contradiction, it's a valid statement. How many solutions do you think this one has?
Infinite.
Say it again. I heard something. Say it again. The contradictions have no solution. This one here is what we call an identity equation.
Mm.
Okay, identity. And basically any number you can think of, if you plug it, is a solution. Any number. Why? For example, if you take 1, you put it here. 1 and 1, it would be 2 minus 2. If you put 3, it will be 6 minus 6. Every time you'll get 0 here, and this will always be 0. So any, basically any real number from the list we talked about the other day, either a decimal or a fraction or negative, positive, whatever, is a solution. So we have infinitely many solutions. Okay, infinitely many, basically all the real numbers. This is a symbol for real numbers. Okay, so remember that. So the first type was all these we've seen before when you have one solution. Those are called conditional equations. Okay, if you end up with a contradiction, just say no solution. And if you end up with an identity like this, with the x gone, so that's when you say it's an identity, it has many solutions, basically all the real numbers. Okay, keep that in mind. So 3 types of equations.
So if we get this on the test, you do want us to write contradiction, no solution, and identity, many solutions, all the real numbers?
That's right, yeah, or at least say no solution. So when we solve, we want to find the solutions if they exist. It would be at least say no solution. If you say this or not, that's not a problem, but you want to specify whether you have solutions or not. So no solutions here, and here you say many solutions. You don't have to explain why, but if you do, that's fine. Everybody else, does this make sense?
Yes.
Okay. Everybody in the room, we have 23 people. Is everyone okay?
Oh, good.
Yes.
Good.
Yes, teacher.
Yes,
All right.
Anybody up? Anybody?
All right, again, please feel free to engage. Feel free to ask questions. And this, again, will be part of your grade, okay? The more you engage, I take note of that. And trust me, that pays off, and it will definitely affect your grade. Of course, I will post this so you guys can rewatch it. Okay, so now let's move on to equations. I'm going to talk about equations with fractions. Let me just fix this stuff here. All right, so what did we call this? A definition, blah, blah. Okay, let's add another section here. I'm gonna call these equations. This type here may require some work in addition to what we said previously. So let's start easy first with simple examples. Let's say 2 over x, or actually the opposite. So let's say x over 2 and 3. So that's a simple first degree equation. You want to get the x by itself. What do you think you do here to get the x by itself?
You need to find
Multiply by the reciprocal.
That's right. So the x is not by itself. We need to cancel this. We have a division between x and 2. There's a division between x and 2. The opposite of division is
multiplication.
multiplication. So you saw earlier that if you have 2x, for example, and 1, multiplication you divide by 2. Now we're doing the opposite. We have this. We just need to multiply here. We're going to multiply by this 2 in order to cancel out. Okay, so that's what we're going to do here. So we need to times by this to cancel it. We're going to times here by 2. Don't forget to do the exact same thing on the other side. We're using this dot as a multiplication to not be confused, or to not confuse the multiplication with the x. So I don't want to use the multiplication here instead of that. It's not a decimal point, it's just a multiplication. Okay, so the opposite of division is multiplication. These cancel out. We end up with x by itself is 6. Okay, so the x is 6. One step equation. There's also the second way to do this. If you have x over 2, and 3, we can turn both into fractions. We have x over 2, we have 3. We can turn this one into a fraction as well. Then instead of doing canceling the 2 by multiplying, what do? We can
Find the LCD.
That's one way to do it, but with only 2 fractions, there's an easier way. Instead of finding the LCD, we can do 2 fractions.
Multiply.
How do you multiply?
Oh, cross multiply.
Yes.
That's
That's
cross multiply.
Which is
If you have one fraction and the other one is not, you can turn it into a fraction. You can easily just cross multiply, or you can do this. You can do either this method or this method. Either will be fine. So this is what we call cross multiply. So x times 1 equals the other multiplication, 2 times 3. So this cross multiplication cancels the fractions, cancels both fractions at the same time. So once you cross multiply, we no longer have fractions. So this times this equals the other multiplication. So this is x and 6. As you can see, it's the same as the solution we got here earlier. But you can use either method, it doesn't matter. Let's see another one. Let's say you have negative 3x over 2. Maybe some other fraction here. The same way again here, we have 2 fractions. We can use the cross multiplication. So, multiply this way. So negative 3x times 5. This way, and then that way. 2 times 1. So this is negative 15x and 2. What's the next and the final step here?
You have to divide.
How about negative 15?
Exactly. So we want to cancel this one, as we saw earlier. We need to divide by negative 15, also here by negative 15. Those cancel out, end up with x equals 2 over negative 15. It's not a problem. The solution can be a fraction. It can be any sort of number. It could be a decimal, could be a whole number, integer, could be any real number, because here x is a real number. Try to simplify it if possible. This does not simplify, so that's fine. That's our solution. Okay, so don't freak out if you see the solution is a fraction. That's not a problem. Just simplify it. You can double check if you're a little skeptical or unsure about your answer. You can double check again, make sure you got everything right. But again, keep in mind, it is possible to have an answer like this. That's the case when you have 1 or 2 fractions. So I suggest you just cross multiply or use a one-step equation here. If not, when you have multiple fractions, that's when things get a lot interesting. Let's say you have x over 3 minus 1/6. Okay, so we have 3 fractions here, not just one. And
Oh,
can you cross multiply here?
Yes.
How would you cross multiply?
No.
you have to find the LCD.
Yeah, so cross multiplying works best when you have 2 fractions only. You still can cross multiply here, but you have to move this over and then combine those, add them or subtract them together until you get 1 fraction here and then cross multiply. But that seems like a lot of work. There's an easier way to do this, which you can use to cancel all these at the same time. And that's by finding the least common,
Denominator.
exactly, denominator. Or what we call the LCD. The least common denominator. This is the denominator, or these are the denominators of these fractions. We want to find a common number or a common multiple for all of these. Once we find that number, we can easily use it to cancel out all these fractions and turn the equation into something like this, something as simple as that, without the fractions. So you should be aware, you should be familiar with fractions at this point.
Oh, it's gonna be 12.
It will be
It's gonna be 12.
12, that's right. So 3, 6, and 4. So the LCD is 12. So all these numbers, 3, 6, and 4, go into 12. Or 12 is the least, the smallest multiple of these. If you do multiples of each one of these, the first one that appears common is 12. So that's your first step. So let me write that down. So first you want to find the LCD. Once you find the LCD, you want to use it. So we're going to say multiply all by LCD. And let's see how that works. Okay, so whenever you see an equation with multiple fractions, first find the LCD, and then multiply all the fractions by the LCD. So let me rewrite this before multiplying. Okay, so we're going to take that LCD, which is 12, and just basically write it next to each one, times, and times here, and also here. Okay, just write it. When we say multiply, we're not multiplying yet. Just write the multiplication, and we'll see what happens before we actually multiply. Okay, now that we did, I don't like the way I wrote this. Let me rewrite it. Oops, the pen doesn't want to work. All right, let me use the undo button. All right, let's try that again. Again, so you want to rewrite your equation without, you don't want to mess up the original one. Just keep it clean, just in case you want to go back to it. You want to take your LCD and basically just write it next to each fraction. Do not multiply yet. We actually want to cancel the fractions. So what do you think happens next?
3 into 12 is 4.
Okay,
So 12 is 2.
that's right. So instead of multiplying, we're not multiplying yet. We're actually going to cancel. Please mute your mic, whoever has background noise. Whoever has background noise, please mute your mic. All right, so before multiplying, we're gonna cancel out 12 by 3.
4x.
That's right, that's 4. And bring down the x. Minus, we're gonna repeat the same thing. We have 12. Reduce that by 6. Be 2 times whatever number here. And finally, 12 by 4, that's 3 times 1. Okay, that's the reason why we find the LCD, because all these numbers go into it. That's why it's an LCD. And if we divide, all of them cancel out. So once you get rid of all the fractions, as you can see, the equation turns into something much simpler. We've been doing this from the beginning. So this is -2. Now we can.
Our 5G nationwide network.
Can you please mute your mic?
200 million people across more than 1,800 cities.
Hello.
So all the pieces have now come together. The coverage of 5G nationwide.
I don't know.
Unprecedented performance of
Andrea, I guess.
Oh, sorry.
It's not me.
Sorry, Professor.
I don't know who has that thing. All right, so okay, so as you can see, that once the fractions are gone, now we can do what we've been doing from the beginning. And And it's much simpler now to solve for x. These cancel out, and you have 5 here. Finally, divide by 4, divide by 4. So x is 5/4. Again, it's fine to have an answer as a fraction. Try to simplify it. If not, that's your answer. Okay, so that's how you deal with fractions, multiple fractions at the same time. You want to find the LCD first. That LCD is used to cancel out all the fractions. Let's look at another one. Sometimes instead of having just x here, you may have x plus 1 or 2x plus 3 or whatever. You could have more than just one term up here. But the process is basically the same. So this is very important. Remember those steps. And once you clear the parentheses, as you see, the equation turns into something much simpler. Let's look at an example like that. So let's say that x plus 1 over maybe, let's see, over 3 plus maybe 1/5, and on the other side, possibly 2x minus 3 over maybe another 5 here. Okay, so again, this looks a bit complex. It's not really that complex. Just have to do a couple of things. So first of all, we have more than 2 fractions, so we can't just cross multiply. So what do you think we do first?
Find the LCD.
The LCD.
That's right. So whenever you see multiple fractions, think about canceling them all at the same time. You have 3, you have 5, and we have 5. Once we cancel that LCD, the equation will turn into something familiar and easier to solve. All right, what is LCD?
15.
15.
Times 3, yeah, 15.
That's right. The LCD is, in fact, 15. What do you do with that 15?
Put it by each.
That's right. Now multiply each by 15. And remember now that we have more than one number here, one term, we need those parentheses because the 15 basically will affect both of these. Here we didn't need parentheses because we had the x by itself, we had a number and a number. Same thing here, we're going to times this by 15. We need parentheses. Do we need parentheses here to times this by 15? We don't. Just put the 15, just a period, or it's fine if you put parentheses, but remember, you must put those parentheses if you have more than one number here. Good, so find the LCD. We put the LCD next to each fraction. What happens next?
You cancel.
That's right, cancel, divide, so 15 by 3. So this will be 5. And 5 times, keep that here, don't distribute yet, just bring that down. Plus, next we have 15 by 5. That's 3 times 1. And we have an equal sign here. Finally, 15 by 5, that's 3. And negative, or 2x minus 3. So again, that's the reason we don't want to distribute yet. You will be a mess. We'll have a 5 here, so instead, we want to cancel all the fractions first. As you can see, this we've seen before. Looks like something we've done here, right? Also, we've done it over here. So the key thing here is to cancel out your fractions because they seem a little intimidating, but nothing too complex about them. Once you get to this point, we already have the steps here. So we want to simplify your side, move the x's to one side, and then isolate the x. Okay, so that applies after you cancel all your fractions. You follow these steps here.
I'm sorry, Professor. I have a question about that.
Mhm.
If in the homework I do like a line with 15 in the bottom, and then I do like all the operation on top, it is correct for you, or you want to have
You
like
wanna turn these into 15s, right? First,
yeah, do like a normal
and then cancel the 15s. Yeah, you can do that. This is a faster way. I think you save time when you do this, but that's fine. You can do that.
Okay.
Okay. All right. So first step again. What do you do here?
You do times 5.
Distribute.
That's right. Distribute. Basically, we're gonna simplify this and this independently. So 5x plus 1 plus 3, 6x minus 9. Okay, work on each side. See if we have like terms. We do. This will be plus 4.
Sorry, Professor, the 5x plus 5.
Plus 5, yeah.
Oh, yes, that's right. Plus
Yeah.
5. So this turns into 8, right?
No,
Okay. Okay, so we simplified each side. What happens next?
We put together the 5x plus minus 6x because we
Exactly.
move from the other side.
Move this over. So 5x minus 6x.
This one over there is minus 8.
That's right. Minus 9. Finally, careful here. 5 minus 6 will be?
Minus x.
That's right. Minus x or minus 1x.
Okay, yes.
And?
Minus 17.
Minus 17.
Professor, I left you a message. Please check it.
Okay. Let me first finish this example and then I'll get back to it. So, negative 1x minus 17. What is the final step here?
Divide by -1.
Divide by -1.
Exactly. Negative 1, negative 1. Finally, x is 17. That's the final answer. We're pretty confident that's correct. But again, you can always plug it to check. When you plug it, you'll plug it into the very first equation, fractions, and everything. Okay, so that's probably as complex as the equation can get. Remember, when you see multiple fractions, don't freak out like I said before. Just find the LCD for those and cancel them all out at the same time.
Okay.
Carrie, that probably answered your questions, right? Your question.
Yeah, but here's the issue. When you did your problem, the answer you came up with was 13, and I don't think that was correct because I believe.
Did I make a mistake like I said before? Maybe.
I think maybe because I think that on one side you distributed and on the other side you didn't distribute all.
Oh, that's possible. That's possible. Yeah, it's always possible to make this cell mistake, just like earlier. I put a 1 here instead of 5. But if you can locate the line of the mistake.
Yeah, I sent you a picture of it.
Oh, okay. Okay, I'll check it later then.
Okay.
But this is what we did today. This is everything I believe everything we did today is accurate. So go by this guide. Go by these steps we did today. What is the chat? Let me find the chat. Someone sent something. Okay, Lopez, no problem. Okay, Lopez, you can go ahead to your meeting or your appointment. One more thing here. One final example. By the way, sometimes if one of these is not a fraction, let's say this is a fraction, this is a fraction. If this is not a fraction, you can make it 1. Let's say you have 2x over 7 minus 1 over 14 equals 3 over 7. Oh, not 7, but just 3. One fraction. You don't see a fraction here. So
1.
That's right. Make this a fraction and repeat the same process. Always make sure everything is a fraction before you find the LCD. And you have to find the LCD for all of them, 7, 14, and 1. And also if you have, let's say, x minus 3 over 6 and 2x minus 1 or plus 1 over 4. We have a couple ways to do this. Either one would be fine. What do you think of those? Give me one of those or both of them, those methods for this. We said earlier, if you have only two fractions, we can
Cross multiply.
cross multiply. So for this, it's probably easier to cross multiply. You can say this times this, so it's 4. X minus 3, and then times these two, so 6. Don't forget the parentheses.
So that would be
Okay, and then distribute and solve just like we did earlier here. Same steps. That's the first one method. What's the other method? It is the same as this, is to find
the
the
LCD.
LCD. Okay, so here you can cross multiply or use the LCD method. Basically, what's the LCD here?
12.
12. That's right, you would put 12 here, and repeat the same process as we saw earlier. Either way is fine. So despite all these methods we saw here, feel free to use your own method. I'm pretty sure people from different backgrounds use different methods. That's not a problem. You don't have to use my method. You can use yours. That's not a problem with me.